In the blink of an eye, we're diving deep into the mysteries of the ocean, soaring to the farthest reaches of the cosmos, tracing the ancient steps of the pyramids and traversing the vast continents of our world. Welcome to your journey through science, space, and the wonders that surround us. From the darkest depths to the brightest stars, we unveil secrets, shatter myths, and ignite curiosity. Here we don't just observe the world, we discover it. We don't just learn, we explore. We don't just dream, we question. If you thirst for knowledge and crave adventure, you've found your haven. Immerse yourself in the marvels of the universe, right here, right now. So, don't just pass by, join us, subscribe, engage, be a part of this extraordinary journey, because the wonders of the world are waiting, and the journey, it's just beginning. In the blink of an eye, we're diving deep into the mysteries of the ocean, soaring to the farthest reaches of the cosmos, tracing the ancient steps of the pyramids and traversing the vast continents of our world. Welcome to your journey through science, space, and the wonders that surround us. From the darkest depths to the brightest stars, we unveil secrets, shatter myths, and ignite curiosity. Here we don't just observe the world, we discover it. We don't just learn, we explore. We don't just dream, we question. If you thirst for knowledge and crave adventure, you've found your haven. Immerse yourself in the marvels of the universe, right here, right now. So, don't just pass by, join us, subscribe, engage, be a part of this extraordinary journey, because the wonders of the world are waiting, and the journey, it's just beginning. Have you ever gazed up at the night sky and wondered, where did all those stars come from? It's a question that has intrigued humanity since the dawn of time. You are not alone in this curiosity. This shared sense of wonder has led to some of the most profound discoveries in the field of astronomy. Today we are fortunate to explore this compelling topic, the riveting process of how stars are born. The genesis of a star is a cosmic ballet that takes place in the most inconspicuous of settings, a cold, dark cloud of interstellar gas and dust, whimsically referred to as a nebula. They represent the cradle of star formation, lying dormant and scattered throughout the vast expanses of the universe. These nebulae, despite their cold and dark demeanor, play a crucial role as stellar maternity wards. Inside these nebulae, the dance of creation commences. Tiny, seemingly insignificant particles of dust begin to clump together. The force driving this assembly is none other than the omnipresent and unyielding force of gravity. This force, ever present, begins to pull these particles closer, forming larger and larger clumps. Each clump, gathering more material, begins to grow in size, marking the first steps in the life of a star. These growing clumps are referred to as protostars. They are the adolescents of celestial world, still undergoing growth and maturation. This developmental phase is vital to the formation of a star. It is in these formative years that the protostar experiences significant changes. As the protostar continues to collect more and more cosmic material, its core progressively gets denser and hotter, evolving and transforming with each passing moment. This is a gradual process, a maturation that takes millions of years. Finally, the core temperature skyrockets to an astonishing 10 million degrees. This intense heat triggers a process known as nuclear fusion. This process marks the transition from a protostar to a bona fide star. Nuclear fusion is no ordinary event. It breathes life into a star. It's the heart of a star's life. This spectacular transformation is the moment when a protostar officially becomes a star. During the fascinating process of nuclear fusion, the most basic element, hydrogen, present in the core of a star, finds itself in a high-speed collision course with other hydrogen atoms. As these hydrogen atoms collide, they do not simply bounce off each other in a random manner. Instead, they undergo a transformative process, a union of sorts, where they fuse together to form a completely different element, helium. This process, as simple as it may sound, is an astronomical powerhouse. It releases an extraordinary amount of energy, so immense that it seems almost unfathomable. This energy is expelled in the form of light and heat. It is this light that illuminates the cosmos, creating twinkling stars that we observe in our night sky. The radiant glow of stars, their brightness, their shimmer, all of it is a consequence of the energy produced by astronomical amounts of hydrogen fusing together in the burning core of the star. Yet, the lifespan of a star is not infinity. After billions of years, a time comes when the supply of hydrogen, its core, gradually dwindles and finally runs out. This event marks a critical turning point in the life of a star. As the hydrogen reserves deplete, the star commences to succumb to its own gravity, gradually starting to collapse under the immense pressure. But this is not a celestial obituary. This isn't the end of the star. Instead, the core of the star undergoes another heating phase. The helium atoms, the product of the initial hydrogen fusion, now step into the limelight. They begin to fuse together, transforming into heavier elements, including carbon and oxygen. This stage in a star's life cycle is often characterized by an expansive phase. The star swells in size, transforming into either a red giant or a supergiant, depending on its initial mass. The final fate of a star, however, depends significantly on its initial mass. Smaller stars, stars that are similar in size to our own sun, will eventually shed their outer layers. What remains will be a dense core, a remnant of its former self, known as a white dwarf. Larger stars, on the other hand, will meet a more dramatic end. They will implode in a spectacular explosion, a supernova, and what remains will either be a neutron star or a black hole. In summary, the life of a star is a journey that begins in a nebula and ends with a white dwarf, neutron star, or black hole. A nebula is a vast, sprawling formation of dust and gas in the far reaches of the cosmos. It's here that the stellar journey takes its first stumbling steps. Under the influence of gravity, the nebula contracts and spins, giving birth to a protostar. This infant star is still not producing energy via nuclear fusion. Instead, it shines to the heat generated by its gravitational collapse. Over millions of years, the protostar continues to accumulate matter and grow in size. Its core temperature increases, finally igniting the process of nuclear fusion, the atomic powerhouse that will fuel the star's life for millions or even billions of years. Upon reaching this stage, the protostar evolves into what we call a main sequence star. The main sequence is the longest period in a star's life, where it maintains a stable balance of forces. Here, the star's nuclear fusion processes convert hydrogen into helium, producing energy that counteracts the inward pull of gravity. This is the time when a star like our sun shines most brightly, radiating its energy out into the universe. Eventually, however, the star exhausts its hydrogen supply. Without this fuel, the star swells into a red giant, a phase marked by rapidly changing temperatures and densities in its core. This is a dramatic, volatile period in the star's life, colored by pulsations, stellar winds, and in some cases of the outer layers. The fate of a star after the red giant phase depends on its mass. Stars with a lower mass will shed their outer layers and leave behind a white dwarf, an intensely hot core made predominantly of carbon and oxygen. This white dwarf will then slowly cool and fade over billions of years. Stars with a higher mass, on the other hand, can explode in a supernova, leaving behind either a neutron star or, in the most massive cases, a black hole. These final stages represent the death of the star, but they are also the source of some of the most fascinating phenomena in our universe. Each neutron star or black hole provides us with a window into extreme physics and the nature of matter under intense pressure. So the next time you look up at the stars, remember the extraordinary journey each one has taken to shine down on you. It's a process that takes millions, even billions of years, and it's happening all across the universe, even as we speak. Isn't that something to marvel at?